हेलो माय डियर स्टूडेंट्स, माय नेम इज सुनंदो देवनाथ। इस वीडियो में हम क्लास 10th केमिस्ट्री का ऑर्गेनिक केमिस्ट्री से आईयूपीएसी नोमेनक्लेचर को समझेंगे। बहुत इंपॉर्टेंट टॉपिक है और आईयूपीएसी नोमेनक्लेचर से तुम्हारा बोर्ड में क्वेश्चन डेफिनेटली पूछा जाता है। तो इस वीडियो को देखने के बाद तुम्हारा आईयूपीएसी नोमेनक्लेचर ऑर्गेनिक केमिस्ट्री का पूरा क्लियर हो जाएगा। तो इस वीडियो को पूरा देखना, सिंसियरली देखना, और जितने भी क्वेश्चंस मैं इस वीडियो में कराऊंगा तुम अपने नोटबुक में भी इन्हें प्रैक्टिस जरूर करना। इसके साथ साथ बुक से भी इससे ज्यादा क्वेश्चंस भी प्रैक्टिस करना। कोई भी डाउट्स होने पर तो मुझे कमेंट सेक्शन में जरूर लिखना। तो चलो वीडियो को स्टार्ट करते हैं।
So, in this video, we will be discussing about IUPAC nomenclature. How do we name the organic compounds? Okay, now the very first thing that one should learn is this particular sequence. Meth, eth, prop, but, pent, hex, hept, and of course, after that, you have oct, non-dec, but then up to this is sufficient. Now, meth is referring to one carbon atom in the main chain. Eth is when two carbon atoms are there in the main chain. Prop is where three carbon atoms are in the main chain. And don't worry, I will explain what do I mean by the main chain. But means four carbon atoms is in the main chain. Pent is when you have five carbon atoms in the main chain. Hex is when you have six carbon atoms in the main chain. Hept is when you have seven carbon atoms in the main chain. And oct is when you have eight carbon atoms in the main chain. Similarly, non is when you have nine carbon atoms in the main chain, and dec is when you have 10 carbon atoms in the main chain, but we are not writing about them because this is sufficient enough. Now, so what is the meaning of main chain? When I say main chain, that is the next important concept. When I say main chain, we have to look for the longest carbon chain. Suppose you have an organic compound like this, carbon connected with carbon, connected with carbon, connected with carbon. Again, you have carbon, carbon, carbon. So, here you have to find which is the longest continuous carbon chain. Suppose if I consider this chain of carbon, which I have encircled with red. So how many continuous carbons are there in this chain? Obviously four. 1, 2, 3, 4. But can we find a longer carbon chain than this? If I take this continuous carbon chain, carbon, 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 this is a chain, right? Carbon, 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 continuous chain. It need not be a straight chain. It can go, it can bend anywhere. We have to just look for the longest chain of carbon. So if I take this chain of carbon, of course, you have more than four carbons this time. 1, 2, 3, 4, 5. Yes. So that means that a previous chain where we had only four carbon atoms would be rejected because we have got a longer chain. But is it possible to even get a longer chain in this figure? I suppose yes. If I take this chain, carbon, 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 and if I turn in this way, again a carbon, carbon, carbon. And if I take in this way, you see this continuous chain of carbon. This is suppose first carbon, second carbon, third carbon. This is fourth carbon, fifth carbon, and sixth carbon. Here I have got even a longer chain. And this is the longest possible chain in this particular structure. You cannot get a longer chain than this. You have to get a continuous. So you have to look for the very simple concept. You have to look for the longest continuous carbon chain. So in this situation, this is the main chain. Now, you may wonder that, so why did you start the numbering from that end? Couldn't we do it like this? 1, 2, 3, 4, 5, 6. In this, from this direction, can we not start? And here also, if we do it in this way, then also we are getting 6 carbons in the main chain. Well, that is also, there's a concept again. From which side will we start the numbering also depends on a particular rule that we will look at later. But now you focus on how do you identify the main chain? The numbering from where we start the numbering 1, 2, 3 from this end or that end, there's a concept, there's a rule again. And in some cases, you can do it from either side. But there's a specific rule also, which we will be talking about later in this video. So I hope you have understood which is the main chain and how do we identify the main chain, longest carbon chain. Now here, that means the base word for this particular organic compound would be hex. Why? Because there are 6 carbon atoms in the main chain. And when you have 6 carbon atoms in the main chain, the base word that would form the name of this organic compound would be hex. Obviously, hex is not the IUPAC name. This is the base word. We will be adding suffixes and prefixes depending on what mode do we have in this particular structure. So the name would have some suffix, have some prefix. Okay, but the base word would be hex. Okay, this is the concept now. Now, how do we number it? Okay, this is what I'm going to discuss now. From which end do we start the numbering? For that, you have to know there is a concept of functional group. There's a concept of functional group. Okay, functional group. Now, the basic functional groups that you have to study, which are in your syllabus, are halides, hydroxyl, aldehyde, carboxyl, then you have ketones, and one ether is also there. However, you don't have to worry much about that because that is not in your syllabus. So basically, these functional groups are in your syllabus. Halides refers to the halogens. It could be chlorine, it could be bromine, it could be fluorine, it could be iodine. So these are the halides or the halogens. You know that these are the halogens, right? Chlorine, bromine, iodine, fluorine. These are known as the halogens, these elements. Okay. Now, when this is one of the functional groups. When you have this halides, any of the halides connected to the main chain, they form a prefix. And I will explain it. How do we write them? A prefix. If a chlorine is connected, we will use the prefix chloro. If a bromine is connected, bromine atom is connected to the main chain, we would use the prefix bromo. If fluorine, then fluoro. And if iodine, iodo. Iodo. Don't worry, we will be showing examples. How do we do that? Just listen and try to understand whatever I'm discussing. Don't, get worried about the examples. We will be doing the examples. Now, hydroxyl means what? Hydroxyl means OH group. Whenever you have an OH group connected to the main chain, we will call it a hydroxyl. And for this, we use a suffix, not prefix. We will use suffix, means we will be adding this word. Which word? The hydroxyl ka suffix is OL, all. OL, all. We will be using this OL suffix after the base word hex because it's a suffix, so it will come after the base word. Prefix will come before the base word. Okay? Base word means the word which depends on the number of carbon atoms in the main chain. For example, in this example, the base word is hex. Okay? And so prefixes or suffixes may come on either sides. That is what I'm telling. So if a halide is connected, a prefix would come like bromo, iodo, chloro, fluoro, depending on which halide has come. If a hydroxyl is connected somewhere, I will show the examples later. So hydroxyl is OH group. So if a OH is connected anywhere, so we will do the suffix OL. Aldehyde, if you have a COOH is connected, CHO. If you have a CHO group connected anywhere, CHO, then we will use the suffix, not prefix again, suffix AL. Suffix is al. Carboxyl is COOH. And here again we use suffix. But the suffix is oic acid. What is it? Oic acid. Okay. like methanoic acid, ethanoic acid. So the suffix would come oic acid. For ketones, it is like this carbon and a double bond with oxygen, double covalent bond with oxygen is there. And at the sides, you have the other carbons connected or yes. So I'm just keeping the arms open like this, other things connected here and here. This is ketone, and for this we use the suffix one, own. It's not one, it's pronounced as own. Okay, for ketone the suffix is own. Now let's take an example and let's do one. Achha, before that, there's one more thing that you have to know before we proceed with the examples. There's one more thing that you have to know, and that is if you have CH3 group connected anywhere. Obviously, CH3 is not a functional group. Okay, it is known as a radical, CH3. If you have CH3 connected to the functional group, and we would call this by the name methyl, not methane, it is methyl. You have to know this. Methane is CH4. Okay, and this is a molecule. It is a stable molecule. It's a stable molecule. Methane. Okay, this is methane. No doubt. You have studied it in lower classes also that CH4 is methane. It's a stable molecule. Okay, even in the chapter atomic structure and bonding, chemical bonding, you have studied that in CH4 there is covalent bond and we have drawn the structure of CH4. So it is methane, a stable molecule. But when you remove one hydrogen from this molecule, it becomes CH3 and it's no longer a stable molecule because the tetravalency of carbon is not satisfied. Tetravalency of carbon means carbon के चारों valency satisfy होना चाहिए. एक carbon के चारों valency. A carbon is should be bonded with 4 different entities. Like in methane, you have on the 4 sides connected with hydrogen. So this is CH4, right? You have drawn the structure earlier also, CH4. So tetravalency is satisfied, 1, 2, 3, 4. But if you remove one hydrogen out of this, then it would be CH3. And this side, you don't have anything, question mark, nothing, just nothing. This is CH3 and this is not stable. So we draw CH3 like this and we draw one line over here because this shows that the tetravalency is not satisfied. Something must attach to it. So this is methyl group, not methyl molecule or something. This is methyl group, or you can also say methyl radical. And similarly, you may have again a C2H5. Okay. C2H6 is ethane. But if you remove one H from ethane, then it becomes C2H5. And again, its tetravalence is not satisfied. We call it not ethane, ethyl. We call it ethyl radical or ethyl group. So keep this in mind. CH3 is methyl, C2H5 is ethyl. Well, now we can do some examples, some nomenclature. Simple ones. Again, then I will talk about alkanes, alkenes, and alkynes after doing a few examples, because you have to look for some more concepts also, but before that, a few examples. Suppose you have this kind of a thing, CH3, CH, CH2, CH, CH3. Well, before that, let me draw it in an even simpler way so that you understand it better, and then I will come to this condensed formula. Suppose you have C, 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 C. This cannot be a stable compound, right? This cannot be a stable compound because all the carbons must satisfy their tetravalency. So let's draw. Every carbon is surrounded by 4 lines. And now, suppose hydrogen attaches on each of the ends. That means there's hydrogen and carbon only. So it is a hydrocarbon. This is the easiest nomenclature which I'm doing. Okay. And here, this is a stable compound, a stable molecule, because you have all the carbon atoms satisfying their tetravalency. So it is a stable molecule. Now, how do we write the name? So you see how many carbon atoms are in the main chain? Well, it's very simple. There is no branch, so you can directly count the longest chain as this, and you can number it from this end, 1, 2, 3, 4, 5. So base word is pent, because there are 5 carbon atoms. And is there any functional group anywhere connected? No, you don't have any halogen connected here. You don't have any OH, CHO, COH, neither this, that, because there's no functional group. You can't see any of the functional groups connected here. So there's no tension. This is the simplest nomenclature I'm doing. Okay, there's no functional group. So if there is no functional group, first of all, you can start the numbering from any end. You can start the numbering from any end. What do I mean? You can number it from this end, 1, 2, 3, 4, 5, 5 carbons, or you can do the either way. You can count it from 1, 2, 3, 4, 5. Both are fine because there is no functional group. But the moment a functional group appears, then you have to follow a rule. From which side will you number? And that I will explain. Now you let us do this first. So pent ho gaya. And if you see, between every carbon and carbon, there is a single covalent bond. What do I mean by this? Look at the bonding done between this carbon and this carbon. Single covalent bond. Again, here, between these 2 carbons, you have a single covalent bond. Between these 2 carbons, you have single covalent bond. Between these 2 carbons, you have single covalent bond. So if single covalent bond exists everywhere between every carbon and a carbon, you don't have to look for carbon and hydrogen, carbon and oxygen, nothing. You have to look for only carbon-carbon bond for the next, suffix that we will be adding. You have to look for the carbon-carbon bond. So everywhere you have a carbon-carbon bond is a single covalent bond. For that, whenever you have a single covalent bond, which denoted by a single line, the suffix that we will write is ane. What is it? Ane. When you have a single carbon-carbon covalent bond. Everywhere, the suffix is ane. But if at any place, if you find a double covalent bond, carbon-carbon double covalent bond, 2 lines are shown and the suffix is ene, not ane. And if you have a carbon-carbon triple covalent bond, then the suffix used is ine, Y-N-E, ine. Okay, in a particular compound, you will have, if you have any double covalent bond between carbon-carbon, it will appear at only one place. Similarly, if you have a triple covalent carbon-carbon bond, it will appear at only one place. And those examples we will be doing. Right now, we are talking about the carbon-carbon single covalent bond only everywhere. So we will be using the suffix ane. So the name of this compound will become pentane. Very simple, pentane. If there would have been any functional group to it, then we would be adding the functional group also in this name. But in this compound, there's no functional group. So it's very simple, it's pentane. But now we are adding a functional group to this compound. Again, I'm drawing the same compound with a little modification, 5 carbons in the main chain. How many? 1, 2, 3, 4, 5. But at any position, I'm keeping a functional group, chlorine, and satisfying one of the carbons tetravalency by chlorine. Remaining tetravalencies of the carbons are satisfied by hydrogen. So this is the next one. Okay, so first one is clear, pentane. Now coming to this, here also you have 5 carbon atoms in the main chain. So the base word would definitely be pent. Okay, I'm writing the P small because something will come in front of it as prefix, because you have a halogen, you have a halide group, and halogen mein prefix lagta hai. Now, which prefix? You are having a chlorine, right? So chloro prefix will come. So you will be adding chloro before, pentane. Yes, you will be adding chloro before pentane. So it's chloropentane, just this? No. You have to also mention the position of the chlorine. And this is where the numbering matters. You have to give the numbering, you have to do the numbering in such a way that the functional group gets the lowest possible number. If you start the numbering from this end, 1, 2, 3, 4, 5, you have obviously 5 carbon atoms in the main chain. But in this case, the number that the functional group is getting is 4. Means this chlorine is getting connected to the 4th carbon atom. But if you number it in this way, 1, 2, 3, 4, 5, then it would mean that chlorine is getting connected to the second carbon. So lowest possible number किस केस में मिल रहा है ऐसे जब मैं नंबरिंग कर रहा हूँ 1 2 3 4 5 because chlorine is getting the number 2 and this is the correct way. So we have to number it in such a way that the functional group should get the lowest possible number. Lowest possible number. So it should be 2-chloropentane. You have to add the position also. Now this is the complete IUPAC name of this compound. 2-chloropentane because you have two chlorines. I mean, sorry, because you have this chlorine connected at second carbon, 2-chloropentane. Clear? So you have seen that chlorine is added as a prefix. Suppose you have two chlorines connected somewhere. Again, suppose I draw, say we have 4 carbon atoms connected this time and a chlorine here, and again a chlorine here, attached to the same carbon. Attached to the same carbon, we have chlorine connected. So H, 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 remaining tetravalencies are satisfied by hydrogen. So the base word would be but. Why? Because when you have 4 carbon atoms in the main chain, the base word is but, right? You see behind. Okay. You have two chlorines connected to the second carbon. See which side we will start the numbering from 1, 2, 3, 4. In this way, if we do the other way, if we start the numbering from this end, 1, 2, 3, then the third carbon is connected to chlorine. But if we do it from this end, then second carbon is getting connected to chlorine. That means 2 is the lower number, right? So we will start the numbering from this end. Okay. From left to right, in this case also. Now the second carbon is having 2 chlorine. So we will write it in this way, 2, 2. And instead of chloro, we will use dichloro. ये हाइफन देंगे नंबर और ये प्रीफिक्स के बीच में एक हाइफन होता है. ठीक है. सो यहां पर हम लोग क्या वर्ड यूज करेंगे? डाइक्लोरो. इफ देयर आर टू क्लोरीन सो वी विल यूज डाइक्लोरो. क्लोरो तो यूज कर ही रहे हैं लेकिन दो है इसलिए डाई मीन्स टू. Dichlorobutane. And see, every carbon has single covalent bond, so the word would be ane, suffix would be ane, butane. You can give a small space between this dichloro and this word butane. So the full IUPAC name is 2,2-dichlorobutane. No confusion? Now, children, look at this. We can even express this formula as a condensed formula. If you see, this is CH3, right? Carbon with 3 hydrogens. So we could have written it as CH3 connected with CHCl, or we can show it as like this, CH and a Cl connected to this. This is CH and a Cl connected to this. Then you have a CH2. Then you have again a CH2 because there are 2 hydrogens connected with chlorine. And then you have CH3 once again. Okay, now you may wonder, sir, CH3, you had said methyl. So are these, why aren't we adding the word methyl in the IUPAC name? It is because if the CH3 is included in the main chain, we would not call it methyl. We would not give it a name like methyl in the IUPAC name. What did I say? If this CH3 is included in the main chain, we would not be using the word methyl in the IUPAC name. Here, all of these CH3s have been included in the main chain, right? Because this entire thing forms the main chain. So all of the carbons of the CH3, if all of the carbons of the CH3 का अगर वो कार्बन इंक्लूडेड हो गया मेन चेन में, तो उस CH3 को हम मिथाइल नहीं बुलाएंगे. क्लियर? वेरी सिंपल. लेकिन अगर वो CH3 का कार्बन मेन चेन में नहीं इंक्लूड हो रहा है तो फिर उसे हम मिथाइल जरूर बुलाएंगे. नाउ यू सी दैट एग्जांपल. दिस एग्जांपल, you have CH3, CH2, CH3. To this carbon, you have CH3, you have CH3. Now, the first thing that you have to see is the main chain of carbon, the longest chain of carbon. If you take this chain, 1, 2, 3, 4, this carbon, 1, 2, 3, 4. Well, this is the longest possible chain. You could have even taken this 1, 2, 3, 4. But again, you have the same thing, right? 4 carbons. 1, 2, 3, 4. If you take this 1, 2, 3, 4, you're again getting 4. So everywhere, if you are getting 4 carbon atoms, so it's best you take the straight carbon chain because there's no longer chain, right? 1 minute, it's erasing. Yeah. Okay. Are you understanding what I'm saying? So if you are having the same number of carbons in the main chain, no matter how do you take the chain, you should always prefer the straight chain. So our longest chain is, I'm just erasing the box. Let me erase it first. Okay. So our main chain is what, which is the main chain? This one, 1, 2, 3, 4. Now, if you see, these two CH3s have been excluded from the main chain. They are not present in the main chain. I mean, this carbon and this carbon have not been included in the main chain. So these two CH3s would be known as methyl. But this CH3 have been included in the main chain, so they will not be referred to as methyl. Are you getting my point? So these two CH3 would be known as methyl, and we have to again do the numbering in such a way that these two methyl groups should get the lowest possible number. So we would be starting the numbering from left to right only, because then these two CH3s are getting the number 2. Otherwise, if you start the numbering from this end, 1, 2, 3, 4, then these two CH3 would be getting 3 number, which is higher. So we would be looking for the lowest possible number. So numbering should be 1, 2, 3, 4. And again, very simple way, we would be writing the name. What is the base word? 1, 2, 3, 4 carbons in the main chain. So the base word is but. All the carbon atoms have single covalent bonds. The suffix would go in. Now methyl we have to show, no? 2 methyl groups connected to the number 2. So 2, dusra wala methyl group is also 2. And there are 2 methyls, right? So we will use the word dimethyl. Just the way we had dichloro, here we have dimethyl. अगर एक मिथाइल होता तो ओनली मिथाइल, यहाँ 2 मिथाइल है इसलिए डाइमिथाइल, और दोनों मिथाइल 2 पर कनेक्टेड है इसलिए 2,2 लिख रहे हैं. दोनों अलग, अगर अलग अलग मिथाइल में कनेक्टेड होता, अलग अलग कार्बन के साथ कनेक्टेड होता, तो फिर कैसे करते हैं? आई विल बी शोइंग इट. आई होप दिस नेम इज क्लियर. 2,2 dimethyl butane. Suppose you have CH3, CH, CH3. Okay, let me just draw the structure. यहाँ पर you have again CH connected to CH3. And you have a CH3 connected. Okay. Now, what is the IUPAC name of this? So again, you have to look for the longest possible carbon chain. You will see that this is the longest possible carbon chain. And to this longest possible carbon chain, you have these two CH3 getting excluded from the main chain. So we will call them as methyl. How to number the main chain? You can do it from either side, because if you give it as 1, 2, 3, 4, the 2 methyl groups are getting the number 2 and 3. And even if you do it from this end, 1, 2, 3, 4, again 2 and 3 only, we are getting the same number for the 2 methyl groups. So you number it from either end, it does not matter. Let's number it from this end, 1, 2, 3, 4. The other side is also fine because the answer would be same. Now here the base word would be but again, because the 4 carbon atoms are there in the main chain. Now 2 methyl radicals are connected. We would be using the word dimethyl itself because there are 2 methyl groups. Dimethyl butane. Okay. So two methyl groups, so dimethyl, and we have to return the position. Here earlier 2, 2, here 2, 3. Okay. Now the sixth one, suppose you have carbon, carbon, double bond carbon, and a carbon, and again a carbon. Yes, this time we are including a double bond between two carbons. Let's complete the tetravalencies. So every carbon should be surrounded by 4 lines. So here this carbon has already got 4 lines. Now this carbon, second carbon already has 3 lines. So only one line would be coming around it. This carbon also has 3 lines, 1, 2, 3. So again, one line. This, this. Now let us satisfy the tetravalencies by hydrogen. Now see, what do we name it as? Here again, the numbering should be done in such a way that the bond, the double bond or the triple bond should get the lowest possible number. So we would not do it from this end. This is wrong because this would give this bond as the higher number. We would be numbering it as 1, 2, 3, 4, 5, so that the double bond gets the number 2. Actually, how do we number it? See, the double bond is between second and third carbon. So we would be saying that the bond is at second carbon. Whenever the double bond is between second and third carbon, we would say that the bond is between second carbon. But if we number it from that particular end, 1, 2, 3, 4, 5, then the carbon is between third and fourth carbon, and we would have to say that the bond is at the double bond is at third carbon. But then third is more a big number than second, right? यहाँ से मुझे number 2 मिल रहा है ना, उधर से मुझे 3 मिल रहा है, तो मैं इसी को चूज करूंगा, 2 and 3, not 3 and 4. So डबल बॉन्ड के लिए मैंने क्या बोला था, इन यूज होता है, ई यानी इन. सो बेस वर्ड तो सबसे पहले हमें पता चल चुका है, 1, 2, 3, 4, 5 है. सो पेंट होगा, लेकिन पेंट इन नहीं लिखेंगे, क्या लिखेंगे, पेंट इन, लेकिन उसमें भी पोजीशन बताना होगा मुझे इन का. सो लिखना होगा पेंट टू इन, पेंट टू इन. दिस इज द नेम ऑफ दिस कंपाउंड, पेंट टू इन. इसमें मैं एक फंक्शनल ग्रुप अब ऐड कर देता हूं, नंबर 7 में इसको कॉपी पेस्ट कर लेता हूं एंड इसे नंबर 7 बना लेता हूं और इसमें थोड़ा मॉडिफाई कर लेता हूं. किसी भी एक हाइड्रोजन को मैं रिमूव कर देता हूं और इधर मैं क्लोरीन डाल देता हूं. अब मैं किधर से नंबरिंग करूंगा, अगर मुझे इन और फंक्शनल ग्रुप दोनों में चूज लोअर नंबर किसको देना मुझे डिसाइड करना होगा, तो मुझे फंक्शनल ग्रुप को लोएस्ट पॉसिबल नंबर देना पड़ेगा. इसलिए मैं इस बार नंबरिंग उस साइड से ही स्टार्ट करूंगा. इवन इफ द double bond is getting higher number, but the functional group should get the priority in getting the lowest possible number. So the numbering should now this time start with 1, instead of starting it from that end, this time it would start from the right side, because right side में करूंगा तभी मुझे क्लोरीन को 1 नंबर दे पाऊंगा. क्लोरीन इज अ फंक्शनल ग्रुप, नहीं तो क्लोरीन को फिर 5 नंबर मिलेगा अगर मैं इस साइड से चलूंगा तो. सो फंक्शनल ग्रुप को लोएस्ट मिलना चाहिए, and in doing that, even if we are giving the double bond higher number, that's okay, but functional group should be given priority in getting the lowest possible number. So numbering उस साइड से किया. तो इस बार भी 5 कार्बन है मेन चेन में, पेंट होगा. इस बार 3 और 4 के बीच में डबल कोवेलेंट बॉन्ड है, थर्ड कार्बन एंड फोर्थ कार्बन. सो यहाँ 3 लिखूंगा, 3 इन हो जाएगा, नॉट 2 इन. पेंट 3 इन हो गया, because the in means double bond appears between 3 and 4 carbon, and first वाले कार्बन पर क्लोरीन है, so 1 क्लोरो. क्लोरीन के लिए प्रीफिक्स आता है, सफिक्स नहीं. पोजीशन लिखेंगे 1 क्लोरो. so ये पूरा नाम हो गया 1 क्लोरो पेंट 3 इन, 1 क्लोरो पेंट 3 इन. ठीक है. सिमिलरली ट्रिपल बॉन्ड भी कहीं आ जाए तो वहां बस आइन हो जाएगा, उसी तरह से बिल्कुल इसी तरह से होगा. पोजीशन लिखना होगा एंड यू हैव टू यूज द वर्ड आइन. एंड एक मैं एग्जांपल भी तुम्हें बता देता हूं, नो नीड टू वरी अबाउट इट. फिर मैं फंक्शनल ग्रुप्स, दूसरे फंक्शनल ग्रुप्स का भी एक दो बता दूंगा. सपोज यू हैव नंबर्स 8 होगा ना ये, यस. CH3, C ट्रिपल बॉन्ड C, CH2, CH3। ठीक है, तो इसमें फंक्शनल, यहाँ देखो ट्रिपल बॉन्ड है, और नंबरिंग हम किस साइड से करेंगे ताकि इस ट्रिपल बॉन्ड को लोएस्ट मिले? तो ऑब्वियसली फ्रॉम लेफ्ट साइड वी हैव टू डू इट, ताकि हमें 2 3 मिल रहा है, तो हम 2 लेंगे। सेकेंड कार्बन में आइन है। हाउ मेनी कार्बन इन द मेन चेन? 5, सो द बेस वर्ड इज पेंट। सेकेंड कार्बन और थर्ड कार्बन के बीच आइन है, सो हम लिखेंगे 2 आइन। कोई फंक्शनल ग्रुप है ही नहीं इसमें, सो इट्स पेंट 2 आइन। अगर कोई फंक्शनल ग्रुप होता तो फिर उसका भी मुझे मेंशन करना पड़ता। वेरी सिंपल। नाउ लेट्स डू दिस। CH3, CH, CH2, CH2, CH3, and you have a OH connected to this CH. Now, where should you start the numbering from? Main chain of carbon ये वाला है, कोई और तो possible chain है भी नहीं. This is the main chain. Obviously, you should start it from this end. 1, 2, 3, 4, 5. Every carbon has been numbered. The numbering has been done from the left end, because then only this OH functional group has got the lowest number 2. Otherwise, it would have got the, if you have started the numbering from this end, like this 1, 2, 3, 4, 5, तो फिर 4 मिलता, 2 नहीं मिलता, लेकिन हमें लोएस्ट नंबर देना पड़ेगा फंक्शनल ग्रुप को। यू नो दैट OH इज अ फंक्शनल ग्रुप, अल्कोहल, राइट? हाइड्रोक्सिल या अल्कोहल बोल रहे हो उसे। एंड OL इज द सफिक्स एडेड, OL याद रखो, फॉर OH ग्रुप। तो मुझे यहाँ OL ऐड करना होगा, और किस पोजीशन में? 2 पर। बेस वर्ड क्या है? 1 2 3 4 5, तो पेंट, और सारे के बीच में सिंगल कोवैलेंट बॉन्ड है, इसलिए पेंटन। ये जरूर लिखना, पेंटन। ये अन कहां से आया? फ्रॉम द वर्ड एन। ठीक है, पेंटन। और सेकेंड वाले पर तुम्हारा OH ग्रुप है, इसलिए सफिक्स लग गया OL, तो 2OL, पेंटन 2 ऑल। और कोई दूसरा तुम्हारा ये नहीं है फंक्शनल ग्रुप। इनफैक्ट इन योर सिलेबस हमें एक से ज्यादा फंक्शनल ग्रुप कनेक्टेड टू ऑर्गेनिक कंपाउंड पढ़ना नहीं है, बट इट वुड हैव बीन पॉसिबल, हो सकता है कहीं पे क्लोरीन भी कनेक्टेड हो, लेकिन हमें एक फंक्शनल ग्रुप का ही करना है, कंपाउंड हैविंग वन फंक्शनल ग्रुप ओनली, so that is only in your syllabus, so don't worry about more than one functional groups connected in one particular compound. So इसका नाम सिंपल हो गया, पेंटन टू ऑल। ऑल क्यों लिखा? क्योंकि यहाँ पे हाइड्रोक्सिल ग्रुप OH था। इसको करते हैं CH3, C, CH3, CH3, CH2, 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 CHO। ध्यान देना, CHO इज अ फंक्शनल ग्रुप, एल्डिहाइड। पीछे देखो, एल्डिहाइड, सफिक्स इज आल। यहां तुमको मिल गया एक फंक्शनल ग्रुप। फंक्शनल ग्रुप के कार्बन को भी हम काउंटिंग में लेते हैं मेन चेन का नंबरिंग जब करते हैं तो। ओके, सो लेट अस नाउ फाइंड द मेन चेन। ऑब्वियसली दिस इज द मेन चेन। अब हम नंबरिंग किस साइड से करें? अगर हम नंबरिंग इस साइड से करेंगे, 1 2 3 4 5 6, सो फंक्शनल ग्रुप इज गेटिंग द नंबर 6, विच इज रॉन्ग। वी हैव टू नंबर इट फ्रॉम दिस एंड, तब फंक्शनल ग्रुप के कार्बन को मिलेगा 1, नॉट 6, फर्स्ट नंबर। So this is correct. In doing so, these two methyl groups are getting the number 5, but that's absolutely okay. Even if they get the bigger number, we have to always focus that functional group को सबसे बड़ा नंबर मिलना चाहिए, सबसे छोटा नंबर मिलना चाहिए, and that we have got. Functional group को 1 मिल रहा है. This numbering is correct. You have to be very careful in the numbering. Always remember, functional group should get the lowest possible number. Base word क्या होगा? Because हमारे पास 6 कार्बन है मेन चेन में, पूरा का कितना कार्बन है वो मत देखना। इफ टोटल नंबर ऑफ कार्बन इन दिस होल कंपाउंड इज नॉट 6, तब तो हमें ये और ये सी को भी काउंट कर लेंगे तो गलत हो जाएगा, तो फिर 8 हो जाएगा। वी हैव टू ओनली सी हाउ मेनी कार्बन आर प्रेजेंट इन द मेन चेन, नॉट द टोटल नंबर ऑफ कार्बन प्रेजेंट इन द ऑर्गेनिक कंपाउंड। मेन चेन में 6 कार्बन प्रेजेंट है, इसलिए हेक्स यूज किया। हियर यू हैव CHO ग्रुप, तो सफिक्स AL जाएगा। हेक्सान, जैसे यहाँ पेंटान लिखा था, यहाँ हेक्सान, फिर पोजीशन है 1, आल, AL, CHO के लिए Al, और पोजीशन आल का क्या है, यानी एल्डिहाइड का क्या है, 1 है, जिसमें हेक्सेन 1 आल। लेकिन हमें ये CH3 का भी फिर लिखना होगा, और ये दो CH3 है, इसलिए डाई मिथाइल हो जाएगा, CH3 मिथाइल, तो डाई मिथाइल लिख दिया। और दोनों ही 5 नंबर ऑफ कार्बन से कनेक्टेड है, इसलिए 5,5 हाइफन डाईमिथाइल हेक्सेन 1 आल, इसका नाम दे दिया 5,5 डाईमिथाइल हेक्सेन 1 आल। कितना भयंकर नाम चल रहा है ना बेटा। नेक्स्ट डू दिस। CH3, CH, CH2, CH2, COOH, और इधर एक CH3 है। Sometimes we do not draw single lines like this. If no lines are drawn, then also we will consider it single covalent bond. These lines sometimes we may not find in some questions. It's a good practice to draw it. Now here numbering हमें देखो, यहाँ COOH ग्रुप है ना, ओइक एसिड मिला, ये वाला कार्बोक्सिल ग्रुप, ओइक एसिड सफिक्स जाता है। तो हमें नंबरिंग भी उस साइड से करना पड़ेगा ताकि इस कार्बन को लोएस्ट नंबर मिले, 1 2 3 4 5, और फोर्थ पे तुम्हें देखो एक मिथाइल ग्रुप मिल गया, वो भी ध्यान में रखना है। बेस वर्ड क्या होगा, 5 कार्बन है, सो बेस वर्ड इज पेंट, और पेंटान लिख दिया। जब भी इस तरह का सफिक्स रहेगा ना, तो पेंटान हेक्सान ये लिख देना। 1 कार्बन पर है ओइक एसिड, ओइक एसिड इज द सफिक्स प्रेजेंट एट विच कार्बन, 1, तो पेंटान 1 ओइक एसिड। और हमारे 4 पर एक मिथाइल भी है, इसलिए आगे जाएगा प्रीफिक्स 4 मिथाइल, ये मिथाइल इथाइल प्रीफिक्स में जाता है। 4 मिथाइल पेंटन 1 ओइक एसिड, 4 मिथाइल पेंटन 1 ओइक एसिड, ये इसका IUPAC नेम हो गया। मुझे उम्मीद है अब तुमको समझ में आ रहा है। नाउ दिस वन, CH3, ये एक्चुअली CH3 है, लेकिन ये कार्बन मेन चेन में इंक्लूड हो जाएगा, तो इसे हम मिथाइल नहीं बोलेंगे। देन यू हैव समथिंग लाइक दिस। नाउ अगर गलती से हम ये सोच लें कि सर ये OH तो है, एंड ये OH तो हमारा हाइड्रोक्सिल ग्रुप होता है, तो गलत हो जाएगा, क्योंकि सिर्फ OH हाइड्रोक्सिल ग्रुप होता है। लेकिन इसको अगर ध्यान से देखो, दिस इज COOH, यहाँ पे C, ये OOH है। एक्चुअली जो COOH हम लिख रहे हैं ना, कार्बोक्सिलिक एसिड का, कार्बोक्सिल ग्रुप का, उसका COOH का स्ट्रक्चर यही होता है। एक कार्बन के साथ डबल बॉन्ड ऑक्सीजन होता है, दूसरा OH होता है। सो दिस इज COOH एक्चुअल स्ट्रक्चर, यही स्ट्रक्चर यहाँ बना हुआ है। एक इस कार्बन के साथ डबल बॉन्ड ऑक्सीजन है, और उसी कार्बन के साथ एक सिंगल बॉन्ड OH है। So you have to be very careful in identifying that this is not the functional group um, hydroxyl. Rather, the functional group is COOH, carboxyl. For this, the suffix that we would be using is oic acid. COOH के लिए oic acid. The numbering would be done from this end 1 2 and not from that end. क्योंकि इस साइड से करेंगे तभी इस फंक्शनल ग्रुप को लोएस्ट नंबर मिल रहा है। 2 है तो एथ यूज होगा, सफिक्स एथ, एथन यूज हो गया, और 1 पर है हमारा ओइक एसिड, ओइक एसिड, और कोई प्रीफिक्स नहीं लगेगा क्योंकि हमारा बाकी कोई ना क्लोरीन है ना मिथाइल ग्रुप है। सो एथन 1 ओइक एसिड। Sometimes it is also written as ethanoic acid. The one is excluded. Okay, ethanoic acid. So I hope IUPAC nomenclature is clear a lot. Okay, if any more doubt exists, you can ask me. Thank you.